So we'll want to have our 7.3 note packets out. So before we start with foiling with trig, I figured let's just make sure we know how to foil with algebra, variables and numbers, just a little refresh, something easy to start us out. Remember, you multiply the first times the first, which would be x times x, which is x squared. The outers, x times 7 is plus 7x. The inners, negative 3 times x is negative 3x. And the last term times the last term, which is negative 21. And then we always combine our like terms in the middle. The same thing's going to happen today. And that would be our final answer there. The next one, we have variables in both spots of the binomial, and that's kind of what's going to happen a lot with our trig today, where you'll see two things. So you'll get 6x squared. Now when you multiply 2x and 4y, obviously you get 8. It doesn't matter if you put xy or yx. I usually put it in alphabetical order, just a personal preference. When you multiply the inside terms and you have negative 1 times 3 and y times x, I would put it in the same order as you put the other one. So put xy so that you realize they're like terms. Otherwise you might think they're not like terms if you put them in different orders. And then lastly, we would have a minus 4y squared. Combine your like terms in the middle, and we should have 6x squared plus 5xy minus 4y squared. Remember algebra? Okay, all that's going to change.
Please excuse this interruption. Indoor track is now dismissed. Again, indoor track is now dismissed. Thank you.
As you look below, instead of seeing x's, you're going to see like sine theta, cosine theta. Same kind of property. Usually I'll give you basically the difference, where you'll see one is a positive and one is a negative, and they're like the exact same. So the middle terms are going to cancel out, but we're going to prove that. Brandon, did you need me to go back?
No, that's fine.
Okay.
I was just...
So, establish or prove each identity. So we're going to start on the left-hand side. We're going to FOIL this. So cosecant times, cosecant is cosecant squared. And if you want, you can leave off the thetas. I know it's obnoxious to have to write them every time. But multiply the outers. 1 times cosecant will be plus 1 cosecant theta. You don't need the 1 if you don't want it. Multiply your inside terms. We'll get a minus 1 cosecant theta. And then minus 1 times 1 is a negative 1 or a minus 1. I'm going to leave everything on this side. I'm just going to bring it down. Equals cotangent squared. So our middle terms, a positive 1 and a negative 1, those just disappear. So we're left with cosecant squared theta minus 1 equals cotangent squared theta, which looks really similar to our formula that says 1 plus cotangent squared equals cosecant squared. It's just kind of rearranged. So you can either have those additional formulas written down on your sheet from like what we did earlier in chapter 6, or you can just use inverse operations. So go ahead and add 1 to both sides. Again, you have to show the work for this. You can't just do it in your head. Like, I want to see the little plus 1 so that I know you know, I know what you're doing in your head, because I can't be there when you're doing it. And then you have your identity. I would like you, when you get the identity, to finish it out with the left side is actually equal to the right side. So since 1 plus cotangent squared is the cosecant squared, I would end with cosecant squared theta equals cosecant squared theta. Check. Left, right, identical. Why don't you guys try the next one? And then we'll do C and D together. Alright, so after we FOILed, we should have gotten this. Our middle two terms do divide, or not divide out, go to 0. 0 sine theta. And then you're left with something a little bit weird this time because you have this negative cosine squared theta. Okay. The easiest way to finish out this problem is to use inverse operations to move things to the other side. So I can add 1 to both sides. If you want, we can do 2 steps in 1. You can also add cosine squared to both sides, but I'm going to do it in 2 steps just in case you're confused. Whoops. So then we would add cosine squared. And then you have the identity. Sine squared plus cosine squared equals 1. Last step is that sine squared plus cosine squared is 1, therefore 1 is equal to 1. C gets a little bit harder because instead of having 1s here, they have another trig function. Okay, but you'll still notice that they're going to be differences, where one will be positive, one will be negative. So your middle terms should still cancel out, and you're going to be left with an identity of some sort. Okay, so we'll start by FOILing. Cosecant times cosecant is our cosecant squared. Cosecant times a negative cotangent would be a minus cosecant theta, cotangent theta. They're being multiplied, you just literally write them right next door to one another. Multiply your inside terms. Those are going to get me a positive. Now again, I would not write it as cotangent cosecant because you may not see these as like terms. I would put it in the same order that you have the other one. Because multiplication is commutative, you can do it in either order, it doesn't matter. So I put cosecant cotangent. And then we have positive cotangent times a negative cotangent, which would be a minus cotangent squared theta. And then I'll just bring down my equal sign, equals 1. So again, the middle terms, we have a minus and a plus, the same exact thing. Those are going to disappear. We're left with cosecant squared theta minus cotangent squared theta equals 1. Looks really similar to that identity, except cotangent squared's on the wrong side. So all we're going to do is inverse operations, we'll add it. We'll get cosecant squared theta equals 1 plus cotangent squared theta, which is the identity. And I'd like to have left and right be exactly equal, so this whole thing is equal to the cosecant squared. So I would get cosecant squared equals cosecant squared. Done. Alright, now before you start FOILing D, let's be working ahead. Some people are still copying, so I'll go in a minute. What looks different about example D than A, B, and Z? There's squares in the parentheses that you're going to have to FOIL. What else is different about them? The number comes first.
Will they become the fourth power, like on the side?
It would, yeah, like it would. We also don't have like the same exact thing with like a plus and a minus. Like all the other ones, like they were exactly the same, just like changing the sign. So it's like your difference of squares. These ones, they have different trig functions and they have squares. So I'm thinking, let's not FOIL first and check, see if we have any shortcuts. Do we know what any of these things are?
1 plus tangent is secant squared.
Good. 1 plus tangent squared is the secant squared. That's a direct formula. 1 plus tangent squared equals secant squared. Now, the other one is not a direct formula, but if you wrote it down on your paper, it is a derivation of one of the formulas we already have. So if you were to actually subtract sine squared, you would get that cosine squared theta equals 1 minus sine squared theta. Again, it may benefit you to have those written down on your paper. You can either copy them from your old paper, or you could just use your other paper that you already have them written on from our last unit a couple sections ago. So this is actually the cosine squared. And then this is really easy, because we know cosine is 1 over secant, or secant is 1 over cosine. It doesn't matter which one you leave. I'm going to leave the cosine. So leave this cosine squared over 1. But the secant is 1 over cosine. So when you have secant squared, it becomes 1 over cosine squared. Those divide out, we're done. 1 equals 1. This is the one, if you look at my answer here, where if you start to FOIL them, you're going to realize it's super long. Like, you have to do all these things with different trig functions, you have to do all these things with different common denominators. So the big key, it's doable, but it's just like a whole sheet of paper of work. If you notice that you have different trig functions and they're squared, look for your shortcuts in your Pythagorean identities. Okay. All right. On the back, we have a couple more. And then maybe we'll just finish these up and not have homework. Okay. So we only have 2 more. And then the closures are easy. They're never as difficult as the actual lesson. All right, now this one, we don't have anything we need to FOIL, right? No parentheses. How do you think I would go about beginning to prove that the left side is actually equal to 2? Change secant into 1 over cosine, sure. Some of you would change cosine to 1 over secant. It doesn't matter. Just pick one of them. But you do want to be consistent and kind of stay in terms. So I'm going to change this to be 1 over cosine squared. Leave this alone because it is cosine squared. Bring down your plus sign. And then what do you think I should change in the second set of terms? It doesn't matter, you have 2 options. Change the cosecant using your formula that the cosecant is 1 over the sine. So this would be 1 over sine squared. Leave the sine squared as is. Okay, these are being multiplied, so the inverse of multiplying is dividing, so that's just 1. Same thing here. 1. And we do know that 1 plus 1 does equal 2. 2 equals 2. Done. All right, last one. This is the longer one. Some students think they can tell me sine plus cosine is 1. Okay. But the Pythagorean identities only work for squares. Okay, these you can add squares to them. These can only work for squares. So just make sure you don't make the mistake that you just change that to 1. It doesn't work. So remember back in algebra when you'd see like x plus 2 quantity squared, you'd have to expand it and then FOIL it. That's what you're going to have to do here. So we're going to have to expand each of these and then FOIL them. So we're going to get, and I'm going to leave off the thetas because this one's long. So I'll get sine plus cosine times sine plus cosine plus, make sure you bring down the plus sign in the middle, sine minus cosine sine minus cosine. And that's still going to equal 2. Alright, FOIL each one. So this will get me sine squared. I will put my theta in here because it looks weird if you don't, but with the squared. Sine squared. This will be plus sine theta cosine theta. Multiply my insides, I'll get also plus sine theta cosine theta plus cosine squared theta. You can combine your like terms if you want, or you can just go ahead and FOIL the second one and see if we can cancel any stuff out, which is what I'm going to do. So I'm going to bring down my plus sign, and then I'm going to FOIL these. This will get me sine squared this one will be minus sine theta cosine theta. Another one, again, when you multiply cosine times sine, you can switch the order to make it sine first, cosine second, so that they look the same, so that you realize they're like terms. And then at the end, be careful, when you multiply two negatives, you do get a positive cosine squared. And then we should see some canceling going on at this point. So I have a positive sine theta cosine theta. I have a negative. I have a positive. I have a negative. Now to save myself from rewriting out all this stuff again, what does sine squared plus cosine squared equal? Bring down your plus sign. And then we're left with another sine squared plus cosine squared. These would all just disappear. That's also 1. And 1 plus 1 is 2. The work is the problem. You have to show the work in order to prove the problem. Okay, try the two closures, and then we won't assign homework since it's Friday. And we'll do this on Monday, because Monday's a practice day anyways. Hey, Sarah wanted to see.
So we can.